Good morning, everyone. Welcome to our webinar, Risk and Uncertainties, How to Estimate, Analyze, and Report Risks and Uncertainties in Project Schedules. My name is Michael Trumper. I'm one of the principals here at Intaver Institute. Today's webinar is going to be an entry-level introduction into how we can use risks and uncertainties to analyze our project risk, and we'll look at ways that we can optimize it. Should be relatively short. At the end, I will do a quick demo in the software just to show how we set that up, how we can set that up, and some of the reports that you can get out of the system. At the end of the webinar, if you have any questions, we do set aside a little Q&A at the end. You can ask them in the chat or the questions pane that are available in the pane that you have on the right side. Generally, it opens up on the right side. Always recommend that you use the computer audio, as it tends to be better. So let's get started. So let's differentiate between risks and uncertainties. Now in this, just having some fun with this, but it's also one of the ways that I can describe it. On the top, we have a risk of a flat tire. So when we drive, we're driving to the grocery store to pick up some groceries. One of the things that could happen and things that can slow you down, one of them is risk events. And one of the risk events could be like a flat tire. Flat tire or running out of gas. It doesn't happen all the time. Hopefully it doesn't happen. It happens very, very, rarely, but it has a probability of happening, and it can have impacts. So it could be a cost. In this case, probably going to be a cost and schedule, maybe safety if you have a blowout when you're driving down the highway at 100 kilometers or 60 miles an hour. And the other part of it is you can manage that. So the things that we can do to reduce the probability or impacts of that occurring. So for a flat tire, I would just make sure that I'm maintaining my car, making sure that the tires are there. And in case it does happen, you can reduce the impact of that also by making sure that you have a spare tire with all the tools that you need, a jack and a lug nut wrench, and those sorts of things. Because that could mean if you unfortunately do get a flat tire, which does happen, because we can't reduce that risk to zero unless you're decide to walk, that would be avoiding it. You can reduce the impact that it will occur. So you don't have a blow up because you just have really old tires, or you do some other things, or you can reduce the impact of it by making sure that you have the tools in place to minimize the impact. So instead of being a 2-hour ordeal when you have to order and get the local tow truck or AMA, your motor association, to come in and get someone to come in and replace your tire for you can do it your own, and it might be just take you 15 minutes. The other side of that is natural variance, which we call uncertainties. And they have a probability of 100%. They always occur during any project. And in fact, in anything you do. This webinar could take 35 minutes, but it could take 20, it could take 30, could take 45, depending on what, on how things go. I'm hoping for 35. But it's 100% probability. And in this one, we're just talking about, if you're on the driving analogy, it's how much traffic is there? Is there more pedestrians? Do you get all of the red lights, or do you get all the green lights, or how many many green lights and how many red lights? And so when you estimate, oh, I'm going to go drive to start, well, it's probably going to take me 10 minutes. But if everything goes well, it could take me 8. But if I hit every red light and school's getting out at the time, unfortunately, and there's lots of buses and stuff, it could take me 15. Thing about that is we define those with it's a natural variance. We define it with a probability distribution. You might think as optimistic, most likely, and pessimistic. And the thing about it too is it's unmanageable. The only thing we can do about it is we can account for it. So we want to have enough buffer or contingency in our plans that we can account for the level of natural variance in the system. Now you need risks and uncertainties. So a well-balanced analysis, we need risks and uncertainties. Both of them impact the project. And if you just do one or the other, you're going to miss a large source of uncertainty or variance in your project that won't be accounted for. Now, depending on the type of projects that you have, the level of risk or uncertainty can change. It's generally, when we look at it, it says, risk or uncertainty, they sort of switch between 40 and 70%. In R&D or other projects, many unknown technical risk events can dominate. In construction or other industries subject to weather or logistical problems, uncertainty often is the main driver of that, as long as the risks are well developed. So the point of this is that there is a balance there, but we do want to have both in the system. We want to have both modeled in our analysis. So this is just a quick look at about the difference that we'll see, and we'll look at the difference when we have, and these are integrated cumulative probability and histograms and cumulative probability, is that with risks, and on the left-hand side we can see the large bar on the left is basically when risks have not occurred, and then we see a couple distributions and spikes, and those are when risks occur. And then we can see with the uncertainties, we have a range that occurs due to the uncertainties, and that the top peak is the most likely that we have at the top here. And then on the left we have, and you can see it changes sort of significantly, and it moves and it gets skewed. The distribution gets skewed far more to the right when we combine the two. So what I'm just trying to show here is if you use just one or the other, you are going to miss and probably have a much more optimistic analysis than you normally have. Risk events. Well, you need a project risk register. It helps if you have limited experience with statistical distributions, because you can do it with a single, you have a probability, and then you can have a single outcome in terms of just a 20% increase or a fixed amount. But it also, you want to do it when you want to identify and manage project risks. So you want to be able to assess them quantitatively. So how do risk events affect project schedule? Each risk event has a probability, as we mentioned, and it has an impact. So it can be an increase in schedule by X days and cost by 20%. And they are assigned to project activities. And in risky project, we can see that. You'll see that if you assign risks to activities, they will appear, they can be visualized on the Gantt chart, as arrows. And down arrows are risks and up arrows are opportunities. So how do we assign them to activities? And we'll show this in the demonstration. We can assign them, and in this particular we're looking at assigning risks in the thing. They get assigned, you can see right here, we're assigning on the left, we've selected a summary activity, and we're going to assign this risk to all of these activities with a chance, which is the probability that will occur. And we've got two different outcomes on this. We're going to have a relative delay with a triangular distribution and a fixed cost increase. Now, whether that's realistic or not, but for an example purposes, you can have multiple. And if you do have non-quantitative, non-project, non-schedule risk, you can assign those to risk categories as well. And how that appears in the risk register, you can always go across and quickly look at on the risk register view, and there's a column that says risk assigned to, and you can see how that risk has been assigned, the assignment. There is a task assignment view where you can actually see much more detail in there as well. So there's a lot of ways to look at this. And risk can be assigned to multiple activities with multiple risk categories. And one or more risks can be assigned to an activity or a resource. So it's like with risks and tasks or resource, it's an end-to-end association that can be developed. Now, how uncertainties affect project schedules. So what it does is it provides, when you look at your Gantt chart, we're assigning a statistical distribution, and it can be, it's right here, it's looking at duration. It can be cost as well. For duration, can be to the end of tasks, and that can be relative or fixed. So the distributions are defined by 3 points. Sorry, it seems to be want to move forward faster than I want to go. And it can be 3 points estimates. So you give it you generate a low, base, and high, and we'll look at how we can generate that. And those distributions can have mean based on a mean statistical deviation or other statistical parameters. We won't go into that. But this is typically what we're going to be doing in for uncertainties in your project schedule. So the problem with uncertainties, they can be very, there's a estimation issue. One of the things is most organizations don't maintain archives of the actuals from previous projects. Historical data is always going to be your best source of how to apply uncertainties or risks to your schedules. So we always want to look at historical data. It can be also that even if you do have that data, previous projects and experience may not be applicable. That's possible. Then in these cases, you're going to be reliant on subject matter experts to be able to provide the answer. The problem with that is that one of the problems we get is we're going to be subject to human cognitive biases, and probably the one that really drives it is anchoring or availability. But the problem is people have difficulty accurately identifying possible boundaries, especially low and high estimates tend to be too close to the most likely. And what happens during anchoring is if we're looking at if we're getting estimates from our subject matter experts, if we provide a duration to it, say it's a 10-day activity, is what they come up with the most likely, and then you ask for a low and high, The estimates will be, for low and high, will be anchored closely to the 10 days. And this tends to generate optimism bias, especially when we're looking at pessimism. So what we want to do is try and mitigate that anchoring and the optimism bias that comes with whenever we're asking people to provide estimates. So there's one solution, and so what we want to do is eliminate the use of units of time or cost. So we don't talk about the actual most likely estimate. What we want to talk about is what is the likelihood of the variance from the most likely. So when we ask for estimates, we don't say, we have this activity, what's the most pessimistic? And they give us back, well, it could be, 40 days. And optimistically, it could be 15 days. What we want to do is ask our subject matter experts to say, how much do we think it could vary from that? So we don't tell them the most likely is obviously thing, but how much, if we have a archetypal project type, activity type, how much could it vary off of that, giving and give that as a coefficient? So in this case, we're saying instead of we got 0.85 and 1.3, so that comes out what the estimates are for this type, for a particular types of activities. Now, and if available, and this is what some of our clients or customers are doing now, because they have historical data, they are going to their work types that they have, historical data for particular work types that they have, and are generating those coefficients based upon their historical data that they have. So let's say it's a grading. They've got historical data on that, and they've gone through and they've calculated, assessed the the optimistic and pessimistic, and the most likely. And the most likely is not the average. Okay? Most likely is not the average. Most likely is the value that appears in that data that appears the most times. So it's not an average. You can use the average, but it's less, because the average is actually a statistical measure. You're using a statistical measure as a marker for on a statistical distribution, which makes it less than optimal. So we want the most likely. So in many ways, it's I've heard it called an ordinal number, but it's the mode, the number the value that appears the most often is your most likely. So what distributions to use when we're doing uncertainties? The one that is recommended is triangular, and often because it's easy to understand when you talk to people about it, they can understand that low, optimistic, pessimistic, most likely. It's very easy for people to grasp, especially if they're not used to talking in statistical or probabilistic views. It does provide more weight at the extremes. So at the boundaries, it's going to provide more weight. I think a lot of times that can be used to mitigate with the optimism bias, especially in the absence of, if you have historical data or good historical data. And like we said, it's recommended. Now, the other one that we like to use is beta PERT. Can use. It's more weighted to the most likely, so the less weight on the boundaries. And we believe that you can. It's useful when it's supported by the data that you have. So the way that we like to model uncertainty is uncertainty bands. Uncertainty bands are basically archetypes for each type of work type that you might have within your project, within your projects. Uncertainty bands have a descriptive name. So we can see in here, we've broken it down on a really sort of, this is a very sort of standard example on construction. Variances are modeled using coefficients for optimistic and pessimistic. The coefficients are used to calculate the boundaries of the statistical distributions. So the low and high estimate, the most likely, it is possible to also use a coefficient for the most likely, which you have in there. It doesn't get used all that often, but if in cases where if you're doing an analysis and you think that the most likely that's been provided, let's say by your schedulers, are inaccurate, maybe a bit too conservative or a bit too conservative or a bit too optimistic, you could shift those as well. Color coding is useful for visually representing the level of risk in the task. And we can see here, if we have a 10-day task, using those coefficients, we can calculate the actual optimistic and pessimistic based on that. So if we're going to assign uncertainty bands, and I'll do a brief overview of how you can create that. We can just select activities within your project schedule, click on the uncertainty band. When you right click on activities, you'll get this menu that pops up. The uncertainty bands, if they're set up, will appear beside that, and you can click those and it will automatically assign to any of the activities that have been selected. If you select a summary activity, it will be applied to all of the activities below it. So reporting that we get out of this, again, using risks and uncertainties, again, just another review of that. So if we use risks, we'll just get a view similar to this. If we use it just uncertainties, and these are cumulative probability and cumulative probability. That curve you see there is the cumulative probability. Probability on the left, cumulative probability on the right. We get sensitivity analysis for both tasks and risks. What are the main drivers in your schedule? And we get a risk, and we can do sort of the risk management piece of that. And we're just showing here's the risk register with the scoring, and here's what we call the risk monitor. So if you've set up your risk matrices and reports, you will get these risk matrix or heat map reports. This one is the risk monitor, just showing how many risks we have in each one of these scores. Recommendations from this: use risk events, and we're going to model major events that can impact project schedules, and we're going to do it to manage project risks. Use uncertainty bands to model variances not attributable risks. So these are the natural variants that cannot be managed. And uncertainty bands provide a structured and consistent approach to adding uncertainties to your project schedule. Use the coefficients. Even if you're not using uncertainty band, use coefficients. It tends to mitigate biases. And one of the things that we haven't done, but we'll show, can be used with risk impacts. And we call it I'm going to call it use a 360 approach. That means we're using all of the, we're including all the sources of risk and variance in our analysis to make sure we don't have any blind spots. With that, I'm going to quickly go over and do a quick demo and show you what it looks like in the software. This is a simple construction. It's a sample that we have within the software. You can see, if you download the software, you'll be able to see this RP construction. So it's pretty simple. You know, around 100 activities. Now, one of the things I do for uncertainty bands, you can set them up. And what I hadn't done in this one is you can set up different levels for different activity types. So if you have activity codes, you can set them up based on that. And that allows you to find those fairly quickly within the system. One of the things I haven't done in here is you can use, and we'll use this one, and you can use coloring. I'll just lighten that up a bit. You can use coloring to indicate the level of risk that these particular uncertainty bands have. So if and the way that we can install those or put them into things. So if I'm going here, I can click here. You can see that I right click, put landscaping, and can assign that. And you can see that it automatically calculates that. Now and those are set up in the uncertainty bands under the risk schedule. Now on the risk side, we have the risk register. One of the things that we can do if you want to assign the risks, we'll just call it procurement. So in our system, all it does, the risks, what they need, and it will develop the ID automatically behind the scenes, but it does need a name. And we can just set it here. If you want to, you can add a lot more data to that. We're not going to do it, we're going to be looking at risk assignments. The way that I like to assign a risk to a system is using the drag and drop. Well, we'll go here, here, and here, just for a thing. And I'm just going to drag it over. So if you look at that, I've selected these summary activities. I'm going to drag it over. And what it does is automatically selects all of those. So the first thing we do is we add an outcome type. Okay, just let me change. I was just changing the way that we can model. So we'll do that again. And we'll just select these. We'll drag that over. And what that did was created the ability to create a statistical distribution. So I'm going to say relative delay. Now I'm going to use relative delay. I'm always going to use relative outcome types if I have more than one activity selected. And then we give a chance that it will occur. We'll say 25%. And then we can select if we want to have a triangular. This is right uniform, so that's a single impact. If we wanted to go triangular, I'm going to go from lowest to highest. We'll say 5. 10 and 20. We'll click OK. And what we'll see is you can see that this risk has been assigned to all of these activities. And then we can, if we want to check that, we can double click and look at the activity level. If we want to, that's not the one we wanted. Here we go. We can check here about how it's been assigned. And finally, we want to see how all the risks have been assigned to the project schedule. We have the risk assignment view. So these are all the risks and how they've been assigned to the project schedule. At that point, to run our reports and get our reports out of this, so the first thing we'll do is get our risk analysis for risks. We don't have any cost risk in this, so we've just got a, and this is the risk scores that we have. So a lot of these, what we're seeing here, they're probably, because it's only schedule risk, we're not going to, these are not landing on the critical path. They don't have any impact on the overall project. They might have on particular milestones, but we can look at that. And this tells us which are the most critical risks that we want to manage first. We can also look at that if we want to look in the risk matrix. And for that, we have risk matrix monitor and history. The other part that we want to look at is what the results are, quantitative results. And if we want to look at finish time, we can see that here. This is duration, often a lot. All of these, all of the results at any level can be pulled out in the analysis view. If we just go up to the probability plot, we get the same sort of analysis in every view. The next major reporting tool that we have that you want is sensitivity. And right here, we can see which are the active. Some of these, there is some tweaking that you can do in terms of sensitivity, in terms of thresholds where it'll show up. But these are our main drivers in terms of task and task duration. So task duration driving finish time. So we use this. If we want to look at the major driving risks in this, we can go and we get the same sort of analysis that we do in the risk register. They don't finish time. Hold it. So none of these are meeting that threshold for on the risk side. But then again, and what this does is allows us to prioritize which risks and which activities that have uncertainties and risks associated with them that we need to prioritize our management experts and management efforts in order to optimize your project schedule. Now with that, if there are any questions or concerns, questions that you have, if you would, you can get a hold of me at, you can email me at mtrumper@intaver.com. You can go on to our website at www.intaver.com to take a look. We have lots of tutorials and other supporting materials there for your review. I'd like at this time I'd like to thank you for your attendance, and because we don't have any questions, we'll be ending the webinar right now.